Good afternoon, everybody. Thank you for coming by. My name's Alex West. I'm the Principal Analyst at IHS, responsible for our manufacturing technology area. I'm going to talk today about the revolution or evolution of the machine and the future of manufacturing. So where are some of these changes going to take us? You know, we hear a lot about some of the buzzwords, IoT, big data, 3D printing, robotics. We hear about the fourth industrial revolution. We really want to take a look today at what's really happening. Where are we seeing some of these technologies impacting manufacturing? And what is the future of the machine? So just to set the scene, when we talk about machinery, we're talking about a very broad range of products. So we're talking everything from agricultural machinery or woodworking machinery through to sort of high-end technologies, so semiconductor or CNC machines. But the size of the market is significant. If you look at the machinery market, if it was a country, by GDP, it would be sitting just behind Brazil and Italy as the 11th largest country in the world. So we're talking about a massive market, a market that today is now sort of dominated by China. China accounts for almost a third of all machines produced in the world. Now, the market has struggled in the last year. You'll see here our forecasts for 2015, or our estimates for 2015, that in many regions there was contractions in production of machinery. Germany was particularly hard hit. Part of this was as a result of exchange rate fluctuations. So this is measured in US dollars. But even if you look at it in euro terms, we're talking about a market contraction of about 3%. In other regions, China, also for the first time this year, we're forecasting contraction as the Chinese economy slows down, as it transitions from more of a manufacturing to a service-based economy, and also as it deals with a lot of overcapacity issues. So these are starting to put a strain on the machinery market. Now, not only this, we're also looking at productivity stagnation. In a lot of the developed regions, you'll see by this graphic, the orange regions are those where productivity growth is less than 2%, less than 2.5%. So many of the developed regions are struggling with stagnating productivity. If you consider the evolution currently of the machine, we had the changes over the last couple of decades moving from pneumatic to electromechanical solutions, and also the transition from mechanical motion control to servo motion. These transitions are, by and large, well established, in place in most machinery. And the question is, well, what's going to lead to improved productivity in manufacturing? How is machinery going to evolve? When we look at the manufacturing market as a whole, there's been a lot of changes recently. I mentioned China, the days of double-digit growth for China's manufacturing sector, those days are gone. The impact of manufacturing wages has changed. So over the period from 2000 to date, we're talking about around a 400% change in the cost of manufacturing labor in China. So really, we're looking at a time now where maybe China was the last location for low-cost manufacturing, and now with the emergence of robotics, it's becoming cheaper to purchase robots in facilities rather than use traditional manufacturing. So this is another new normal. Oil prices have changed. You know, the days of $100 plus per barrel oil prices, these have gone. So we're looking at a market that's under a number of new normals, and technology is really going to be a key to another change in creating a new normal for not just how machines operate, but some of the associated elements that I'd like to talk about today. So firstly, IoT. So there's been a lot of buzz about IoT, big data. You know, you can talk about having your Nike app that tracks the number of miles you've run and uploads it onto the internet, or tracking the food that you eat and monitoring your health. Now, these are a lot of consumer-based IoT applications that are already starting to gain some traction. But within the industrial market, adoption is a little bit slower. So I'd like to just give an overview of where we are today with IoT. So currently, IoT is really at that point of connecting and collecting. So connecting devices using field bus technologies and then transitioning over to Ethernet technologies to allow for collection of data and then transmitting that. The benefit of Ethernet technology is that you have the ability to transmit information from the factory floor all the way up to the enterprise level. And also collecting this information through the use of sensors. So we're seeing more sensors being rolled out in applications, but also better use of this sensing information, whether that's measuring things like pressure and temperature or vibration and speed. More sensors being rolled out. And that's really where we are today in the manufacturing sector. Now the next step is, we've collected this data, what are we going to do with it? And then that's really what a lot of companies are struggling with at the moment. How do we actually drive any value from the data that we're collecting? Now, we see that some of the companies at the bleeding edge in manufacturing have started to utilize the cloud and are uploading information on the cloud to support with analytics. There's a lot of work being done in terms of development of algorithms that can sift through huge amounts of data from varied sources to provide some insight. So the next step is really that accessing the data and the analytics. Now, cybersecurity is going to play a big part in really having rollout of IoT being successful. There's a lot of concerns still about sharing of data, putting data on the cloud, having more devices connected. If you think more devices connected, especially those with Ethernet that then have an IP address, means a greater surface area of attack through cybersecurity, through cyber hackers, whether that's to cause malicious damage and downtime in a facility, or if that's to steal production data. So cybersecurity is one big issue that needs to be looked at. But the end goal is quite compelling. When you look at the ability of what can be done through collecting all of this data, it can create a visibility across the supply chain, from understanding what your customers need, through to knowing about your suppliers' delivery, and really having that visualization across the whole supply chain, even in terms of understanding your asset health, to really provide some unique value. However, this unique value, we're still a number of years away, and there's still a lot of questions that need to be answered. So I've got here some examples of what are some of the real benefits that we can get from connecting devices, collecting this information, really applying some analytics. And not just looking at IoT, but broadening this to digitalization as a whole. So one of these is digitization. So this is the creation of software that provides the ability to create a digital twin of a physical system or a physical product. Now this can be used, and we've seen some examples at the show here of companies that are designing motors on software and then simulating performance of those motors, so creating a simulation of the performance, understanding the impact of changing parameters, increasing speed, increasing temperature. What does that do to the motor? But it's not just at the component level. This can be rolled out across to creating a digital simulation of your entire plant. There's some significant benefits in terms of not only understanding how assets will perform under different parameters, but also giving training opportunities for workers, for example, those that will have to operate control systems, giving them the ability to get training, understand how these control systems will actually operate. Remote diagnostics and monitoring is another technology that's really available already. So this is the ability of an end user who's purchased a machine to press a button either on the computer, or sometimes it's a physical button, giving the end user the ability to connect to the machine, the original machine builder, giving the machine builder the ability to provide training, provide monitoring services and diagnostics. So this is opening a new revenue stream for some machine builders. The problem with this is, whilst the technology is there and it's a simple case of pressing a button to create a VPN, there's still a lot of concern between coordinating operation between the IT department and the OT department. The OT department may well see the benefit of sharing this data. However, the IT department is always very sensitive about what is allowed to be opened up to the outside world. So sometimes there is this barrier between IT and OT that really hinders rollout of some of these solutions, such as remote diagnostics. Mass customization is also quite an interesting direction that the market is going in the future now, this is really creating a batch size of one. This could be in cereals. So there's a company, a cereal manufacturer that offers the ability to create muesli with 80 different types of ingredient. So a customer can go online, select the ingredients they want, and a fully automated system will then sort out through to final delivery of the product. But it goes all the way through to high-end products such as within the automotive industry. We know many car manufacturers now are offer the ability to customize your automobiles. I was reading recently about the Dodge Viper. They now offer the ability to customize with 21 million different variants of the Dodge Viper, whether that's your wheel trim, your aerodynamic profile, color, interior, the ability to really customize every element of the machine, so the car. So really, no two cars might ever be alike with a Dodge Viper. And it's not just in the machinery market, it's also happening. There's a lot of work being done in the pharmaceutical industry around customization of medicine. Different people have different body sizes, different needs in terms of medicine. And some of the pharmaceutical companies are looking at the ability to customize drugs for individual people. However, the real low-hanging fruit around some of this collecting data and analyzing it is that of around predictive maintenance. Currently, when you look at a lot of traditional maintenance programs, these are either reactive or preventative. So reactive maintenance is something breaks, I have a spare part, I go and fix it. Preventative maintenance would be, I have a maintenance schedule and I plan every X amount of months, maybe every 6 months, I will go and visit my products, review them, maintain them, maybe replace them. But these are very, very costly. You're talking about greater risks of downtime, inefficient use of maintenance staff. Really the next step as we collect more information, more data, is companies will be able to understand the health of their assets. So a good example is maybe on a gearbox where a company may add vibration sensors on a machine or on a gearbox, and as a ball bearing starts to degrade, it'll start sending out atypical signals. A company that has collected a history of the performance of their assets will then know this gearbox has, for example, 3 months or 5 months of lifetime left before it reaches a critical failure, and they can plan their maintenance in advance to ensure there's no downtime. Now, the next step goes even beyond predictive maintenance, and that's prescriptive maintenance, where as companies have a greater history of data and an understanding of the performance and the lifetime of their devices, they can actually use this data to adjust the load on the machine, adjust the throughput of the machine to ensure the lifetime of the machine is extended and fits in conveniently with some of the maintenance schedules they may have. So really getting a far better understanding of the health of assets. But it's not just technology that's changing. And I mentioned at the start the Industrial Revolution. And people have said, well, are we in the fourth Industrial Revolution? Is it just an evolution? And from our perspective, from a technology point of view alone, we're talking about an evolution. Ethernet has been in place for well over a decade. Sensors, collection of data, even basic analytics. These are not new technologies. But there are other elements that are going to be transformed, and there is going to be a revolution. One of these is around the location of manufacturing. If you look at how manufacturing changed from 2003 to 2015, again, this looks at the production of machines. Where machines were made was transformed. China created this great opportunity with a wealth of low-cost labor. Many companies outsourced manufacturing, creating this globalization. However, as mentioned earlier, with wages going up so much in China, it's no longer the most cost-effective place to manufacture. In fact, it's cheaper to manufacture in Serbia or Czech Republic. Robots are coming into the market, and companies are now looking to localize manufacturing, so produce their product closer to their end customer, and also at the same time reducing the supply chain and reducing costs. Standardization is going to be important. So there was a recent announcement by the EU that they were planning to coordinate the raising of 50 billion euros to support the digitization of manufacturing in Europe. This is investment in creating a European manufacturing cloud and centers of excellence. And there's a lot of similar initiatives worldwide. If you go to America, you have the Industrial Internet of Things. In China, you have Made in China 2025. Japan, Taiwan, Korea, these all have their own initiatives. But the key is that many companies are global companies in nature, and it's going to be critical that there's standardization to ensure that the benefits from these solutions can be fully realized worldwide. When we're looking at relocation, this is a statistic from the Association of German Engineers. 20% of companies present in China currently plan to pull out as a result of the increased wage costs. And many of these companies are those that purely outsourced because of the cost of manufacturing locally. So this is now being brought back. So I've touched on technology. As I mentioned, we expect there to be a move to reshoring over time, especially as companies make the most of technology to shorten supply chains and reduce costs. But there are a number of other transformations that we think are going to impact manufacturing and the machinery market. Probably the most significant change is going to be that of business models. So the company GE, they're the second largest manufacturer of aerospace engines in the world. And they're using predictive analytics. They've placed additional sensing on their engines. They're collecting this data. Typically, a jet engine or an aeroplane will generate from the engines alone about 1 terabyte of data each flight. It's a huge amount of data, but what GE are doing is now collecting this data, analyzing the data to understand the performance of their engines. So what is the lifetime of the engines? When is it going to fail? And they've transformed their business model accordingly. GE are no longer primarily a seller of aerospace engines. They're working with their customers to provide uptime. So they guarantee the maintenance of the engines. If a failure is due to take place, they'll make sure they have engineers on hand to repair or, if needed, replace the engine. And selling a long-term contract that is purely uptime and not based on the sale of product. And this isn't just something that's happening in the aerospace industry or for higher value assets. Pirelli are doing something very similar on their truck fleets or on their business with trucks, with fleet management. So they're now offering predictive maintenance on their truck tires. And again, selling uptime of truck tires rather than selling individual tire products. So we see this as more data becomes available, the ability to analyze performance of product becomes more visible. Companies are going to shift the business model. One of the threats is that predictive maintenance is generally going to mean your products are going to last longer. If your products are lasting longer, the likelihood is you may well be selling fewer. And companies are looking at other business models to really drive additional revenues. We're starting to see a number of companies now mention moving themselves away from being a supplier of product and stating that they are now providers of software and services. This is something that's been very strongly done by companies like GE and Siemens. It's not just business models that are going to be transformed in the manufacturing space. Suppliers as well, the companies that are addressing this market are changing. Those that went to the Hannover Messe recently, you'll see there was a transformation in terms of some of the companies that were there. There was huge presences from a lot of the IT companies. Companies like Microsoft, SAP, IBM had big presences there. They're going to be critical in enabling this wave of analytics and creating value from these analytics. But they're not going to be able to do it on their own. They don't have the partnership with the end users, and the automation vendors and machine building companies, they don't have the expertise in providing cybersecurity systems or cloud-based services. So partnership is going to be crucial in ensuring a lot of these benefits are enabled. Companies' skill sets are also going to change. I mentioned the need for partnership between IT and OT departments. There's going to be a challenge for companies. Data scientists is an area where some of the biggest shortages in recruiting. You know, we talked, historically there was talk about engineering shortages. Well, the same issue definitely holds true amongst data scientists. Automation is also going to change, you know, how it's provided, how it's connected, where intelligence sits on your automation solutions as well. Just as I close, I'd just like a bit of audience participation. If I could just ask you to raise your hand if you own either a Motorola or a Nokia phone. Does anybody here have a Nokia or a Motorola phone? Nobody. Okay. So this graphic here shows in 2007, Nokia and Motorola accounted for over half of all mobile hand shipments in the world. Only eight years later, combined they account for less than 3%, and neither of them, these two companies, actually exist in their own right anymore. Microsoft acquired Nokia, Lenovo acquired Motorola. And it's an illustration that things change, markets change. We were speaking to some machine building associations and understand there's a real divide. Some machine building companies are saying, our data is very sensitive. It's very important that we don't create access with all this information. We need to build walls to make sure nobody can hack into our systems. And there was another party of machine builders that say, look, the opportunities are great. Look at all the things we can do. There's new revenues that are achievable. And so I'd like to leave you with this quote. When the wind of change blows, some people build walls, other people build windmills. Technology that's starting to impact the manufacturing space is going to be transformational. It's going to take some time. Those companies that don't have an IoT solution now, it's not too late. But in the future, the landscape of suppliers is going to be transformed by those that react. So, a couple of points just to summarize my presentation. You know, just to reiterate what I said, the landscape is going to change. Business models will be transformed. Technology is going to evolve. There's going to be new companies coming into the market. And it's going to be companies that adopt to these changes and start looking into other service and software solutions that are going to be the ones that are going to succeed in the future. So that's all I have for you. I think now we've got a time for some questions, if anyone has any questions. We've just got a mic.
What's your view of 3D printing?
I think 3D printing's an interesting opportunity. So really when you talk about 3D printing, I guess you mean in the manufacturing space, right? So in the manufacturing space, it's already being well used in things like prototyping and creating of fixtures and fittings. There are still some pretty big limitations in terms of cost. Material costs as well as cost of the actual printing machines, the speed of the machines, the ability to print different materials. But at the same time, there is a lot of development taking place in these areas. So we don't see any time in the near future that 3D printing is going to be a solution for mass production. But definitely the opportunities around customization of products. I mean, you can now, there's companies 3D printing golf clubs. Nike and Adidas are looking into 3D printing for printing the soles of footwear. So there are going to be some very unique applications where 3D printing is going to transform the industry. In terms of the real mass production, you know, think of the automotive industry and supplying parts to, say, a VW or a Ford. We think that's still a long way off. But on the flip side, if we're talking about small batches, they've already 3D printed the first car. So I think there's a lot of opportunity. Okay, maybe just one quick question from my side. Of the audience here, could you raise your hand if you actually use data, big data, as part of your manufacturing or your operations? So you collect vast amounts of data and use that for analysis. Does anyone do that? Not yet. Okay, well, hopefully next year we'll see more hands raised in terms of those using their data to support their manufacturing processes. Okay. Thank you very much, everyone.